All right, so for this video, we're going to start with number 12. It is a calculator problem. And we have to substitute in the numbers they're giving us in the correct variable and simplify. So 144 feet is distance, so time equals 0.92, the square root of 144 over 16. I type that in the calculator. So this equals 2.76 seconds. For 13, they give us 40 miles per hour, which is a speed. So we're going to plug that into S. To solve, we're going to square both sides. And divide by 18. We get to 4 decimal places, so that's 88.8889 miles. No, that can't be miles. That's not right. Oh, distance is length in feet, so 88.8889 feet. Okay, so now for 16 and 17, the population is increasing. So this is the formula we're going to use. It starts at 5,000. 0.025 is the decimal for that percent to the T. Now, 1920 is 20 years after 1900, and then 1950 is 50 years. So for both A and B, we're going to plug in the different values to get the ending population. And because it's people, we don't include a decimal place. And then we're going to change the 20 to a 50. We should label our answer, so people. So now for 17, because we're losing, it's decreasing, our equation is 1 minus r to the t. So A is writing the equation. And then for B, it is 10 years, so we're going to plug in 10. And we get 149,684. Okay, so for 18, now we're dealing with money. And it's being compounded monthly. So we're going to use the compound interest formula. We start with $6,000, 4%. Monthly is a unit of 12, and after 5 years, we're going to plug in 5. And for these problems in the calculator, I like to type the pieces of the formula in pieces so that I make sure the calculator does the order of operations that I want it to do. And because it's money, we're going to go to the nearest cents. That's $7,325.98. For 19, compounding continuously is this equation. We deposit $1,000. Interest rate is 1.4%. And 8 years. The key for this problem in the calculator, when you type your exponent, you have to include a parentheses around the rate times time. Okay, so now for 20. 5 p.m. Well, since it's since noon, that's when time is 5. And it says nearest whole number, so that's 57,861 bacteria. And then B, corrected 3 decimal places. How long will it take to reach 120,000? Now, we can solve this either graphically or algebraically. I'm going to choose to do this algebraically because I don't like resetting the window in my calculator. I'd much rather use a logarithm to solve it. So we 8 equals e to the 0.27t. To solve that, if we want to change it to a log, the e term has to be on the left to use the Roman numeral 9 rule. So ln of 8 equals 0.27t. So the ln of 8 is 2.079, and so on. And if we divide by 0.27 on both sides, time is 7.702 hours. Okay, and for 21, ten years from today is going to be 66,000. Oh, and today it is 22,000. We have to find the rate. Okay, so we're going to start by dividing by 22,000. So we get 3 equals e to the 10r. To be able to change it to a log, I'm going to put the 3 on the right. So ln of 3 equals 10r. So ln of 3, we're going to divide by 10 to isolate the r. But now the rate as a percent, if you move the decimal 2 places, and then we need 3 it says 3 places after the decimal. Okay, 29, the solving. We have to subtract 5. And now we can change it to a log. And we have to write the answer to 3 decimal places, so we're going to do log of 21. We have to add 3 to both sides. So that's log of 21 plus 3. And then we'll divide by 2. Log 21 plus 3 divided by 2 is 2.161. And now for B, we're going to add 17. Oops. So we have 5 ln of x plus 4 equals 25. We have to divide by the coefficient. We're going to change it to exponential and subtract 4. So let's see, e to the 5th minus 4, 144.413. Okay, and lastly for C, we're going to divide both sides by 3 to start. Change it to a log. So that's going to be ln of 9. We're going to add the 2. And then divide by 5. Okay, so now for 31, we have to decide what kind of model best fits this data before we can use our calculator to get a function. If you look at the y values here, it's times 3. So that's going to be an exponential. Oh, I can actually write the equation now without my calculator. B is 3. This is our a value. So now we're going to plug in 9 to x. That's 2 times 3 to the 9th. So 39,366 people. All right, for 37, inversely related. So we have T varies inversely with the rate of the pump. So to write the relationship, I need to find K. So they give us 60 minutes, and they give us 230 gallons per minute. So to solve that, we're going to multiply by the 230. So K is 13,800. Oh, that's the answer to B. I guess for A, we can just use the setup with all the variables. Okay, so now for C, we're going to plug in. Let me write my equation Okay, so there it is with k filled in, the constant. How long will it take if the rate is 300 gallons per minute? So that is 46, and our unit is minutes. Okay, for 38, y varies directly with x and inversely with z. 9, 2, and 12. Okay, so let's find k. 9 times 12 divided by 2, so 54 is k. And now plugging in the other numbers they give us, 54 times 3 divided by 10, 16.2. And for 39, the light intensity is inversely proportional to the square of distance. So now we have to find k. 23 is I over 5 squared. So 23 times 5 squared. Our k value is 575. What is the intensity if it is raised to 6.5 feet? So 6.5 is d. And 3 decimal places makes that 13.609.